is exponentiation commutative. Compare a to the power of b and b to the power of a. Quite clearly, both are different. A to the b's power equals to a multiply a for b times, okay? And the other one is, the base is different. B multiply how many times? A times. So these two are completely different. Students can plug in numbers to see for themselves. Is exponentiation associative? Compare a to the power of b to the power of c, and then a to the power of b to the power of c, whether these two are the same. So I suggest students can use, say, a equals to 2, b equals to 3, and c equals to 4 to find this out. These two are different. Explain why 7 to the power of 5 and then to the power of 3 equals to this. Again, this, I suggest students just carry this out. By definition, 7 to the 5th, if we look at it as one number, to the power of 3, that is 7 to the 5th power, multiply how many times? 3 times. So if we write each one out, this one is 7 multiply 7 multiply 7 multiply 7, 5 times. This is also 5 times. This is another 5 times. So how many 7s are multiplying together? We have 5 7s multiplying together. We have 5, another 5, and another 5. So that is 15 7 multiplying together. So it gets to this answer. Practice problem 4. For this one, the division, we can always write it as in a vertical form. 2 to the 7 multiply 2 to the 8 divided by 2 to the 3. This property we have mentioned earlier. A to the power of m multiply a to the power of n equals to, they are the same base, a to the power of m plus n. So then this one would become same base, right? There's 7 2 multiplying together, 8 2 multiplying together. So total there will be 15 multiplying together. And take out 3 from the exponent, it will be 2 to the power of 12. And we this one we want to talk a little bit. So again, we write it as vertical form, 16 to the power of 3 divided by 4 to the power of 3. Multiply a to the square. These, all the powers have different bases. We can change this. 16 is 4 multiply 4 to the 4th power divided by 4 to the 3rd power. Multiply 8 is 2 multiply 4 to the power of 2. Again, going back to our original property, let's see, where is that? So a multiply b bracket to the power of n, you have to have a to the power of n and multiply b to the power of n. Okay, each one has to have the power. So coming back to this, first term you'll have 4 to the power of 3 multiply another 4 to the power of 3 divided by 4 to the power of 3. Multiply here again 2 to the power of 2 multiply 4 to the power of 2. So this cancel and students can carry this out. Okay, these two have the same base. This one is not. But 2 to the power of 2 is what? 4. So you can collect the terms. Practice problem 5. Simplify this expression. So we can see that these are all same numbers, right? So 1, 2, 3, 4, 5. 5 multiply 5 to the 17. 5 is what? 5 is 5 to the power of 1. Again, we're coming back to this property, okay? The students can figure this one out. Part B, can you explain why a to the 0 is 1? What is a to the 0? The a to the 0 is, we can look at it as a to the power, well, we go back to lecture 1. You have a number and you have the inverse of it. So x minus x equal to 0, right? We can use x minus x to replace the 0 here. So we have the first term is a to the x. The second term is a to the minus x. A to the x is on top. A to the minus of x is a to the x on the bottom. So therefore, that gives you 1.